Hi, good evening to all of you.
Good evening, sir.
Can you all hear me?
Yes.
Yeah, a bit louder. Yes. Can you all hear me?
Yes.
Yes.
Yes. So, hi, class 10 students. I think I'm meeting you for the first time. So, I'll give you a brief introduction about me and then we'll start your session. I'm Sandeep Singhal. I did my BTech from IIT Roorkee in the year 91. And it's been like 27 years of active teaching. I spent around 15 years in PACE, and and I love teaching. So my father was also a professor of physics. He was a scientist. My mother was a professor of English. So it became easy for me to understand what this competitive world is. And so many years back, because I came from a family where my parents were not just educated, but were in the field of education, the journey became simpler. Now, once I decided, when I completed my engineering, I'll just take a few minutes to introduce myself and then we'll start the flow because ये जानना भी तो जरूरी है कि पेशेंट किस डॉक्टर के पास आ रहा है ये जानना बहुत जरूरी है आई I मीन कोई कोई बीमार है ये थोड़ी कि किसी भी कहीं भी जाके घुस जाएगा किसी भी डॉक्टर के पास नहीं मिलेगा वो देयर इज अ डॉक्टर ही इज सेलेक्टेड हिमसेल्फ फॉर सो दैट इज व्हाई आई एम गिविंग यू अ स्मॉल ब्रीफ इंट्रोडक्शन सो बच्चों जब मैंने अपनी इंजीनियरिंग कंप्लीट करी आई वेंट टू माय डैड एंड आस्क्ड हिम व्हाट डू आई डू नाउ ही सेड व्हाट डू यू डू नाउ मतलब you've done your engineering now you know what you have to do but I didn't know. And after completing 27 years and training so many students, my students, after doing their engineering, doing their MTech, they come back to me and ask me, अब क्या करना है सर? तो वही सवाल मैंने अपने डैड से पूछा, अब क्या करना है डैड? तो he said, you have to search for yourself. It looks so simple, कितना आसान लगता है ना, अपने अंदर झांक के देखो, अंदर कहाँ झांक के देखे? अंदर तो कुछ दिखता ही नहीं है. मैंने डैड से बोला मैं कहा डैड एक एक इनबिल्ट प्रॉब्लम है कहता क्या हुआ मैंने कहा जब मैं अपने आप को नॉक नॉक करके पूछता हूं ना नॉक नॉक मेरा कुछ होगा क्या तो अंदर से जवाब आता है भाई तेरा कुछ नहीं होने वाला मैंने कहा डैड अंदर से तो नेगेटिव फीलिंग आती है करना क्या मेरे को मालूम नहीं है सो माय फादर यूज्ड टू टीच फिजिक्स देयर वर लाइक बंच ऑफ 40-50 kids he used to teach them physics my father was a scientist as I told you one day while teaching he fell ill he had to be admitted to the hospital. जो बच्चे वहां पर थे मैं इंजीनियरिंग करके आया था दो स्टूडेंट्स स्टार्टेड आस्क मी फॉर हेल्प सर कैन यू हेल्प अस मैंने कहा यार मैं तुमसे 4-5 साल बड़ा हूं पढ़ के आया हूं पढ़ाना नहीं आता तो एक बच्चा बोलता है सर पढ़ा पढ़ के पढ़ा देना सर व्हाई डोंट यू स्टडी एंड टीच अस देन आई स्टार्टेड टीचिंग फिजिक्स एंड व्हेन माय डैड केम आफ्टर 3 months after when he recovered he saw that they were almost like in those times bicycles पे बच्चे आते थे there were almost like 700 bicycles outside the house and I was teaching physics chemistry and mathematics I was doing this because I wanted to help my father but in this process I understood what I want to do in life and that yes I wanted to teach 27 years now I'm still teaching I'm still active and I still love teaching and that is exactly why I'm here for. Now, in class 10th, you've done mechanics, you've done laws of motion, kinematics, work power energy, and then electricity, and you were doing magnetism, or you finished magnetism, and now the time was to start optics. Light optics. We call it light optics. Now, before I move forward, because I'm meeting for you for the first time, I'm going to play a challenge round with you. I'll ask you a few questions, those questions from those topics which you've already done, जो आप पहले से कर चुके हो. मैं उनसे आपके से कुछ सवाल पूछूंगा. If you answer it correctly, and you are the first person to answer that question correctly, you get a cash reward of rupees 1,000. I play the game like this. I like Kaun Banega Crorepati. So let's play that game. I'm going to ask you one or two, three questions, and then I would know where the understanding level is, and then we are going to push ourselves to optics or light. Are you ready? I want my students, they can switch on their cameras. You can probably, if you want, you can unmute yourself and start the WhatsApp chat is on. You can start writing your answers. So I want to first know, are you ready for the challenge? How many of you like challenges? Okay, yes. Parsh says yes. He's from Borivali. Okay. Oh my goodness. Akshat says yes. Vandita says yes. Lavangshi says yes. So yes, let the competition begin. Let's see who answers this question first. And the first question on my screen, और बहुत आसान सवाल पूछ रहा हूं, काइनेमैटिक्स का क्वेश्चन पूछ रहा हूं. यहीं से आज शुरुआत करते हैं. This is y-axis. This is the x-axis. And there is a particle which is moving in a straight line. There is a particle which is moving in a straight line. This is x-axis, this is y-axis, this is a plane. A particle is moving along this line. Now, my question to you is this a 1D motion? Option 1, or is it a 2D motion? The student who gives the answer first, Vandita says 2D, Siddhant says 2D, Ayush says 1D, Tanay Rawat says 1D. So there is a conflict. There is a 2D and a 1D happening at the same time. Now, Akshit, why don't you switch on your mic, Akshit, and tell me, why do you think it's a 2D motion? Yes, Akshit. Vandita, you want to answer this? Why did you say it's a two-dimensional motion? What is your thought process behind it? Does anybody want to answer this question? Why do you think it's a 2D motion? Sir, my mic is not working. Akshit says my mic is not working. Okay, that is possible. Anybody who says it's a 2D motion? Okay, Sparsh Sethia, you say it's a 2D motion. Unmute yourself and answer the question. Yes,
Sir,
I'm listening.
it is 2D motion because if you take 2 points on the line, then the y-axis mein the y of the point and then the coordinate of the point will be different for both of those points. So it is changing, so it's 2D.
You're absolutely right in what you are saying. You know what he's saying? Sir, by the way, 1D motion का मतलब क्या होता है? मैं पहले सर मैं आपको वो बता देता हूं. सर 1 का मतलब तो 1 ही होता है. D का मतलब डायमेंशन होता है. 2, it is a one-dimensional motion. And when I say this is a two-dimensional motion, right? यही बोलते हो ना आप? So this young man says, sir, when this particle is moving along a straight line, and probably when this particle is here, I want to measure the value of x. I drop a perpendicular, that's x. I drop a perpendicular here, this is y. I can measure this distance and I can see this distance is x1, y1. But the moment I reach here, I again drop a perpendicular on the x-axis, measure this distance, this is x2. Measure this distance, drop a perpendicular, this is y2. Sir, as I go up, both x and y are changing. So that means they should be a two-dimensional motion. सही बात है, सही बात लग रही है ये. अब मैंने किसी बुक में पढ़ा, I read this in one book, which by the way is H.C. Verma. That book says, now see the irony. From this, we are sure that this is a two-dimensional motion because both x and y are changing. But यार मैंने किसी बुक में पढ़ा था, बड़ा इंटरेस्टिंग चीज पढ़ा था. बोलूं, लिखूं? ओ बड़ा इंटरेस्टिंग चीज ये था, when a particle moves along a straight line, then it's a 1D motion, one-dimensional motion. Sir, ये तो पंगा हो गया. This is very confusing. Both the dimensions are changing, should be 2D. body is moving in a plane, it's moving in a straight line. Both x and y are changing, should be 2D. But sir, book में तो ये भी लिखा है when a particle moves in a straight line, then it is a one-dimensional motion. अब मजा आएगा. The axes assumed are incorrect. No. I mean, somebody could say, sir, मेरे दिमाग में एक चीज आ रही है. मैंने कहा बोल. कहते सर मैं इसको x ले लेता हूं, इसको y ले लेता हूं. अब ये पार्टिकल अगर इधर जाएगा तो ये वन डायरेक्शन में जा रहा है, बट अ लॉ हैज टू रिमेन लॉ. ऑब्जर्वर के रिस्पेक्ट में चेंज हो सकता है, डायमेंशन चेंज करने से अ 1D विल नॉट बिकम अ 2D. A 2D will remain a 2D and a 1D will remain a 1D. So this, what I said, doesn't work. If it works at one case, it should work with all the cases. And that is the dilemma of this question. This is the first question of kinematics, which says a particle moving in a straight line, is it a 1D motion or a 2D motion? Now I'm going to give you the correct explanation. So have you written this down first of all? I know we are meeting for the first time, लेकिन मैं बोलूंगा जल्दी से दोस्ती कर लेते हैं. टाइम नहीं वेस्ट करते हैं. Let's create a bond between us. Start answering questions. I hope you've written this down. अब मैं इसका explanation देता हूं तुमको. बड़ा इंटरेस्टिंग explanation है. I'm going to redraw it again. X-axis, y-axis. And this particle, we assumed is moving in a straight line. And our question is it a 1D or a 2D motion? अब बच्चों जरा ध्यान से. 1D motion. You know what motion exactly means? What is the exact definition of motion? Now, motion means, sir, when a particle is moving with respect to time, that means it can cover distance. So can I say motion is distance? So like when it moves, it could have a displacement also. Now, do I say it's a motion is basically displacement? Do I call motion as velocity? Do I call motion as acceleration? Or do all these things represent motion, or some of them represent motion? That is the question. And we want the right answer. We need only one answer. And the answer lies with only one gentleman who created this law. The Newton, Isaac Newton, exactly knew what he meant when he defined motion. When I went to Mr. Isaac Newton's house and I pressed the bell and I asked him, sir, what do you exactly mean by motion? When you say one-dimensional motion or a two-dimensional motion, what is motion for you? And he said, for me, motion is velocity. That's how life becomes simpler. That's how you start solving problems. So the moment you say motion is velocity, now it's one-dimensional velocity. And now comes the greatest differentiator. This is not dimension. This is directional. This is not dimensional. It is directional. D-I-R, directional velocity. One directional velocity is what we mean by a 1D motion. 1D motion is one directional velocity. 2D motion means a two-directional velocity. Now, ये तो सब कुछ बदल गया सर, ये तो सब कुछ चेंज हो गया. 1D motion suddenly becomes one directional velocity. Now, a student asks me, the next question, follow-up question should be, sir, how do we find direction of velocity? How do we find the direction of velocity? Somebody said, sir, displacement upon time is velocity. That's the magnitude. Velocity is a vector. It has both magnitude, it has direction. Magnitude is displacement upon time. Direction is what I'm asking. How do we find direction of velocity? Anybody wants to answer that? If I have a path and I want to find the direction of velocity, कैसे निकाल सकते हैं उसको? कोई बताएगा मुझको? Okay. Tell me one thing. If I say a particle is moving in a circular motion, if I tell you that there is a particle which is moving in a circular or motion, And I asked you to calculate the direction of velocity here. What do you do? What do you do to find direction of velocity? If I ask you a particle is moving in a circular motion,
Tangent.
what do you do? Draw a tangent.
Tangent.
Very good. Ashwant, Aditya, Siddhant Singh say, sir, please draw a tangent. This gives you the direction of velocity. And if this circular motion is in the anti-clockwise direction and I wish to calculate the direction of velocity here, I draw a tangent. I wish to calculate the direction of velocity here, I draw a tangent. These all tangents give me the direction of velocity. So to find the direction of velocity, what do I do? How do I find the direction of velocity? By drawing, somebody would want to complete this, by drawing a tangent. Very good. On what? On the path. Path is a circle, path is a straight line. You draw a tangent, you find the direction of velocity. Path को physics में आगे जाके आप पढ़ेंगे is also called trajectory. You are PACE students. जो बच्चे PACE में पढ़ते हैं वो या तो पराग अग्रवाल बनते हैं, है ना? अगला पराग अग्रवाल ढूंढ रहा हूं मैं, मेरे को तुम्हारा साथ चाहिए. I want you to focus. You're good kids. I can see from your chats, I can see that you're doing very well. You're trying to answer. Ab agle half an hour, I'm going to take your class till 9 p.m. That's 40 minutes from now. Total focus, ask your doubts, and let's make this session one of the most amazing sessions. आएगा भी, मजा आने वाला है आपको. क्या बोला आपने? By drawing a tangent on the path, you get the direction of velocity. अब आना बच्चों इधर, ये path ही है ना? It's a straight line, is a path. If I want to find direction of velocity here, what do I do? Draw a tangent. What do I get? The direction of velocity. If I want to calculate the direction of velocity here, what do? I draw a tangent and I get the direction of velocity here. Oh my goodness me. All the vectors, all the tangents are all in the same direction. If all the tangents are in the same direction, that means all the directions of velocity are in the same direction. And if all the directions, velocity directions are in the same direction, this is a one-directional velocity. This is a 1D motion and not a 2D motion. I hope you loved it. Did you enjoy this discussion of mine? How many of you enjoyed it? Give me a thumbs up. I need it. I need to know, are we going in the right track? Very good. Thank you. That's very, very encouraging. Yes. Because the idea is, आप जितना आगे जा रहे हो, आप पीछे का भूल तो नहीं रहे हो. I want to check that also. So this is one discussion I wanted to have since you all loved it. Now, I ask you the second, should I take one question from laws of motion or should I start with optics? एक सवाल और पूछूं challenge आपसे, या should I move on to optics? Write it on the chat box. Laws of motion, okay, you want the challenge. You want the challenge. So let it be. Then we'll start optics in the next class and let's go to the next challenge. Now, the next question, the next challenging question is going to earn you, if you do it correctly, 1,000 rupees. Are you okay with this? Are you game? Are you game? Are you ready for this challenge? 1,000 rupees if you answer it correctly. And if you don't answer it correctly, then you at least know what you have to study, what is the right answer to that question. So let's start the competition. I'm sorry, I thought I would teach you optics, but I thought it is class 10th. देख लेते हैं शुरुआत में कैसा खेल रहे हो आप लोग. Next question. Ready? There is a mass. I've kept it on the surface of the earth. There is gravity acting. This mass is m. This mass is m. This force is mg, the force of gravity. There is a normal reaction. which you applied like this, and you call it N? Yes, you do that? You do that. Now, my question to you is, my dear friends, is N a reaction to Mg? If
Yes.
N is the action, is N the reaction? Yeah, you can unmute yourself.
Yes.
Okay.
Yes.
Lavangi says
Yeah.
yes. Akshay says yes. Suchitra says yes. I think yes, but probably. Ashwant Aditya has a very interesting answer. He says, I think yes, but probably no. Oh God, that's so confusing. So he feels it is yes, but then he feels that it might not be right. Now let's see why Ashwant is thinking that it might not be right.
Well, actually, no.
Actually, no. And why did you say actually no?
Because as we see, the mg is exerted by the core of the earth on the body, but
Hmm.
the normal force is put by the surface of the earth on the body.
Hmm. Anybody else wants to contribute?
They're not acting on the same body, right? So if it's so, how is it they're not acting on the same body?
Wow. And who's this speaking?
Ashwath.
अश्वथ बात है यार भाई मजा आ गया अश्वथ अश्वथ बोलता है सर सारी बात को खत्म कर देते हैं आप पूछ रहे हो इज दिस एन रिएक्शन टू एमजी सर फॉर श्योर इट इज नॉट रिएक्शन टू एमजी बिकॉज एक्शन and reaction do not act on the same body is what the Newton's law third law taught us that to every action there is an equal and opposite reaction but act on two different bodies.
They
So,
act on different
yeah, you're
bodies,
right.
but mg is the force which the body applies on the earth.
Correction, correction. Mg is the force which is acting on the mass exerted by Earth. This is better. That's much better. Speak it again. You can speak it again. What is Mg?
mg is the force that is applied on the body by earth.
है ना आप पूछोगे सर कैसे ऐसा क्यों है भाई इफ आई टेक दिस बॉडी मिड एयर सपोज आई टेक दिस बॉडी हियर एंड दैट्स अर्थ एंड आई रिलीज इट रिलीज कर दूं उस बॉडी को मैं जस्ट छोड़ दूं तो इसके ऊपर भी एमजी लगने वाला है अगर मैं इसको मास को सरफेस पे प्लेस कर दूं तभी भी एमजी लगने वाला है बिकॉज एमजी इज द फोर्स एक्टिंग ऑन द मास बाय अर्थ तो फिर बच्चों ये बता दो एमजी का रिएक्शन अगर एन नहीं है तो फिर एमजी का रिएक्शन कहां है कहां लग रहा है कहां पर है वो रिएक्शन ओके दिस इज अलंकृत आई एम इम्प्रेस अलंकृत गो ahead you want to say something Siddharth Singh also says there is something on the earth Vandita says on the earth very good Ashwant says ab ek baat batao how would I know where the reaction is I haven't studied sir I don't remember simple thumb rule अगर A पर फोर्स B लगा रहा है उतना ही फोर्स B पर फोर्स A लगाएगा मास पर फोर्स कौन लगा रहा है अर्थ की वो फोर्स कहां से लग रही है अर्थ तो ऐसे होती है इट्स इन अ स्फेरिकल शेप दिस इज द सेंटर दिस mg is the force exerted on mass by the center of earth ये जो फोर्स है इसको अगर मैं आगे बढ़ाऊं तो ये सेंटर पर लग रहे सेंटर से पास करेगा सो इफ दिस इज द एक्शन द फोर्स विच इज एक्टिंग ऑन m by the center of earth where will the reaction be absolutely right it will be on the center and towards the mass so this value is also going to be mg so if this is action this definitely should be the reaction do you understand what I'm saying have you all understood this completely? Yes or no? I want to know the answer. Have you understood this? Very good, very good, very good. Now, if this is action and this is the reaction to mg, then what is n? N क्या होता है फिर? What is n in this? How do you pronounce N? What is N, by the way?
Normal force.
जोर से बोल, normal reaction. N is the normal reaction or a normal force, right? ये force मास के ऊपर ऊपर क्यों लग रही है? क्यों हो रहा है ऐसा? ये पेन को, हाँ, it's a type of a contact force. It's a contact force. हो क्या रहा है? So when you place this body on your hand, what does this mass do? It pushes the hand downward. And what does the surface do? It is an elastic surface. It will try to push it backwards. So the moment you place this M on the surface of the earth, the surface of the earth will become, is not liking it. It's going to push it upwards. So if this is the action, where is the reaction then?
On the
N का
surface
reaction
of the
कहां पर है?
earth.
कहां पर है?
On the surface of the earth.
Surface of the earth. And this is going to be this. So if this is the action, this is the reaction. If I draw the free body diagram of M, by the way, and that is where the students get confused, mg and reaction are the net forces, not the action reaction forces. Have you understood this? Have you understood this?
Yes, sir.
Wonderful. I'm liking it. So you know it. I'm very impressed. PACE के बच्चे हैं, आता ही होगा. So now I have another 30 minutes with you. And I'm going to start now what you came for, and that's light or optics. And the competition still remains. I hope as I know, you studied light in class 8th, did you? Or 9th? When did you
Ninth.
last study light optics? In class 9th, yes?
9.
And in class 8th also?
Yes, sir.
And what's the first law? Law of reflection.
Angle of incidence is equal to angle of refraction.
And the
No.
second law?
All the incident ray, and the
The
reflected ray, and the
reflected ray and the
all lay in
normal lie on
same
the same plane.
So do you want to play a Kaun Banega Crorepati with me?
Yes.
First question on your screen. Why is the angle of incidence equal to the angle of reflection? My question is why? Whoever answers this. Tanay, Rawat, yes, you can unmute yourself. Tanay, and you can speak. Yes. Why is the angle of incidence?
Sir, when light travels, it wants to travel between the shortest distance between the two points where it wants to reach.
Okay.
And so, accidental consequence of this is the angle of incidence is equal to angle of reflection.
So the consequence of that light takes the minimum time or travels the minimum distance, reaches you to angle of incidence equal to angle of reflection. That's what you're suggesting?
Yes, sir.
Can you prove it? Can anybody prove it? Okay, I'll help you. I'll definitely help you. Now tell me, you said light travels or takes the minimum distance. It travels the minimum distance. Yes, you said that? Is this some sort of a law or you feel so? Is this a law or you just feel like that?
It's nature.
It's a law. Sparsh says it's a law. Akhansh Mishra says law. What is that law called? Kanshik Salve says, impressive. Kanshik says,
My name is Kanishk, sir.
the Fermat's principle. Yes?
My name is Kanishk, sir. Not
I'm sorry,
Kanishk.
Kanishk.
Yeah.
हाँ यार थोड़ा दूर से दिख नहीं पाया Kanishk. Hi
No,
Kanishk. I'm so
sir.
happy to know that.
No
Can you
worries,
tell me
sir.
what is Fermat's principle?
So basically, Fermat's principle is like basically like the light travels in between 2 points with the path that requires the least, like the least, like the most least amount of time.
Would you
And
Okay. Again,
And
go ahead.
then like when you see, then when light reflects, in this case we're talking about a flat surface, the path that it takes, it's the least amount of time it takes is where the angles are equal.
Okay. Okay.
That-
Anybody else wants to come in?
I have a slight hunch about this.
Yeah. Go ahead.
Can we reverse engineer the? It may sound a little off-putting, but am I welcome to say this?
Go ahead.
Can we reverse engineer the laws of refraction? Can we
We can
use
prove,
laws,
we can prove
the
all
Snell's
the
law?
laws of reflection and refraction by Fermat's principle. Give me 10 minutes and you would love what Fermat exactly said. Let's listen to what he said. You want to listen that? Okay. Ready?
Yes, sir, of course.
Have you heard of an ellipse?
Yes, sir.
Yes, sir.
This is how an ellipse looks like. Do you know that it has two focuses?
Yes, sir.
I'm very, very happy. Do you know what is the property of an ellipse?
Sir, the
The sum of the
Equal
distances
from
yes, some of
if
the
sum
two
of the distances
distances.
from
If I
any
is
take a
point
point
equal
P1
from any
here,
point.
if I take a point P1 here and I measure this length, F1 P1 plus P1 F2. If I measure this length and then I take another point here, call it P2, and measure this length, oh my goodness me, that's F1 P2 plus P2 F2. Do you know these lengths are equal?
Yes.
Do you know this?
Yes,
Yes,
sir.
sir.
अब जानते हो फॉर्मेट ने क्या किया? भाई कमाल कर दिया उसने. उसने कमाल कर दिया. उसने इस एलिप्स को एक मिरर बना दिया. He converted this ellipse into an elliptical mirror. और जानते हो उसने क्या किया? क्या देखा उसने? वो बोलता है कि जब मैंने सोर्स ऑफ लाइट को यहां पर रखा, सोर्स ऑफ लाइट मतलब यहां से इंसिडेंट रेस को निकलना है, वो बोलता है भाई ये कमाल की बात हुई. कहता क्या हुआ? कहता यार यू वुड बी सरप्राइज टू नो ये इसका फोकस 1 था, ये फोकस 2 है. फोकस 1, फोकस 2. फोकस 1 पर एक सोर्स ऑफ लाइट रखी. And you know what he said, what he saw? The ray of light which was reflecting from here reaches this point, passes through the other focus. A light ray which reaches this point passes through this focus again. And a ray of light which passes and crosses this focus also reaches this point. इस सोर्स की इमेज दूसरे फोकस पे बन रही है. अगर सोर्स में एक फोकस पे रख रहा हूं तो उसकी इमेज दूसरे फोकस पे बन रही है. कि कैसे पॉसिबल हो सकता था? वो वापस उसने एलिप्स की बात सोची. उसने कहा यार एक बात बताओ, मतलब अगर ये पॉइंट P1 है और ये पॉइंट P2 है, आपने तो बताया था ये डिस्टेंसेस बराबर होते हैं. मैंने कहा हां. कहता अब आप कह रहे हो कि अगर मैं सोर्स ऑफ लाइट को फोकस में रखता हूं तो सारी की सारी रेज रिफ्लेक्ट होकर यहीं से पास कर रही है. इसका मतलब this incident ray after reflection, when it forms an image, travels a certain distance. This incident ray hits the mirror and reaches this point. That means all these rays are taking the same distance or traveling the same time. This is so amazing. What it tells now is, now Fermat, what he says is that all the incident rays, all these incident rays, after reflecting from the mirror, when they form the image, all these incident rays reaching and forming an image are traveling the same distance, are traveling the same time. Do it, write it down. Did you find it interesting?
Yes, sir.
इतनी धीरे से क्यों बोला तूने यस सर? या तो जोर से बोल यस सर, या तो बोल नो सर. How many of you understood this? Or you want me to
Yes, sir.
repeat it again?
Can you repeat it again?
Yes, sir. How is the distance the same?
I'll tell you again. When I say what is a straight line, and when I say what's a circle, आप ये बोलते हो सर ये स्ट्रेट लाइन इसलिए है क्योंकि इसके हर पॉइंट पर कोई भी सेगमेंट लेता हूं मैं, उन सबका ये एंगल सेम है, which means tan theta is same, which means slope is same. मतलब basically locus of all the points which have the same slope is called a straight line. What is a circle? I take any point here, any of these points here. All these points are at a same distance from the center, from a point which is basically called a center. So locus of all the points which are equidistant from the center is a circle. Similarly, there is a property of an ellipse, which is this, that if it's an ellipse, these are two focuses. If I take any point here, measure this distance, and if I take any point here and measure this distance, both the distances are equal, is the property of an ellipse. Fermat started, he knew it because he was a mathematician. He knew what an ellipse is. He did an experiment. What he did was he converted this ellipse into an elliptical mirror and placed a source of light here. To his disbelief or to his shock, he found that all these rays which started from this point, the source, all these rays after getting reflected from any point actually reach the same point, which is the other focus, which means this is the object, this is the image. That means this incident ray gets reflected, reaches here. This incident ray gets reflected, reaches here. All these rays, incident rays, after reflection, take the same distance to form an image. So any incident ray which has to finally form an image, all those incident rays have to travel the same distance. That is what he formulated in his first principle. He did not stop here. उसने यही नहीं रोकी बात को, वो एक स्टेप और अहेड जाता है. वो ये बोलता है, फर्स्ट स्टेप में क्या बोला उसने? That all distances traveled, I want you to write this please, traveled by an incident ray. Yeah. All distances traveled by incident ray to form an image. Seriously, form an image. Take same distance or take same time. My goodness. Either they travel same distance or take same time. That's the first thing he said in the Fermat's principle. And as I said, he did not stop here. He moved a step ahead. And you know what he said? My goodness, you'll be मजा आ जाएगा तुमको सुन के. और वो ये बोलता है कि ये जो सारी की सारी रेज है ना, ये सेम टाइम तो लेती ही हैं. All rays, all incident rays take the minimum time to form an image. Oh my God. Do you understand what I'm saying? मतलब ये सारी की सारी रेज यहां से यहां जाके यहां आ रही है, यहां से जाके यहां आ रही है, ये सबके सब डिस्टेंसेस सेम है, ये सबके सब टाइम सेम है, और ये जो इंडिविजुअली टाइम ले रहा है, ये इस रे का हिट करने के बाद यहां आता है, ये इसका मिनिमम टाइम है. इट इज द मिनिमम टाइम इट टेक्स टू फॉर्म एन इमेज. हैव यू अंडरस्टूड बोथ ऑफ देम? यस माय डियर फ्रेंड्स, हैव यू अंडरस्टूड बोथ द लॉज? इसको करने के बाद अब आएगा असली मजा. So I keep telling this story to all my students. I had a student called Arnav Agarwal who was ranked 19 in the country, 19. I asked Arnav, यार जब 19 आ गई थी तो 1 भी आ सकती थी? कहता हाँ सर. मैंने कहा तेरे को सारे क्वेश्चंस आते थे ना? कहता हाँ सर. तो मैंने कहा क्या हुआ? माइंड फॉग हो गया? क्या हुआ? कुछ नहीं सर, लास्ट के 15 मिनट्स में थक गया था. लास्ट के 15 मिनट्स में माई एनर्जी लेवल वेंट डाउन. फ्रॉम दैट डे मैंने कसम खा ली, वेन एवर आई टेक अ लेक्चर This examination is 3 hours, or any examination, 2 hours, 1 hour, JEE का हो, NEET का हो, कोई भी Olympiad, कोई भी exam हो, there is a time allotted to that exam. Generally, our mind gets fatigued in the last 10-15 minutes. देखोगे ना स्कूल के बाद जब लेक्चर खत्म होता है लगता है कि अब खत्म होने वाला है. Your mind gets diverted from the attention where you wanted it to be to a place where you don't want it to be. So last 15 minutes of a class are the most crucial 15 minutes of that lecture. We are in the last 15 minutes of the time, and I want you to perform in the next 15 minutes. Are you ready for that? Are you ready for that? Yes, students. तैयार हो आप लोग?
Yes, sir.
जोर से बोल. Yes, sir. Komal, are you ready for it? Will you take the challenge? Okay, let us do that. So there are two things I told you. All distances traveled take same time, and individually all incident rays which
Yes.
form an image take a minimum time, right? Now, tell me one thing. Just a minute. Let me just mute it. Give me a minute. Yes. Okay. Now tell me one thing. Do you know calculus? Do you know what is dy by dx?
Yes. Yes, sir.
Sure.
Yes, sir.
Yes.
अब 15 मिनट मजा आने वाला है. Get set ready. Let's prove. Now let's prove. Class 10th. Let's prove. Why is the angle of incidence equal to the angle of reflection? We want to prove this. We have on our side the Fermat's principle. The Fermat's principle, as you all told me, basically tells us that light takes the minimum distance to form an image. You agree with me? Are you ready for the challenge?
Yes, sir.
आ जाओ. I take a plane mirror. This problem came in physics Olympiads, by the way. And PACE students को आदत है tough questions की, tough situations की, challenging situations की. There you have it. I'm taking a source of light here. There is an incident ray. There is a normal. This is called the angle of incidence. मजा आने वाला है, ready हो जाओ बच्चों. And this ray reflects, and we call this angle as R. यहां पर स्क्रीन रखिए, इमेज बन गया. I want to prove the relation between I and R. And I know what's Fermat principle, that it takes the minimum distance to form an image. अच्छा, तो मतलब रे यहां से यहां तक और फिर यहां से यहां तक जो डिस्टेंस ट्रैवल कर रही है वो मिनिमम होना चाहिए. इज दैट व्हाट Fermat said if it has to form an image? देखते हैं खेल का मजा. Okay, this is source, that's the mirror. Let me drop a perpendicular here and call this height as h1. Ready? ठीक है. It's a constant. If I drop a perpendicular, this distance is going to be a constant. Similarly, I drop a perpendicular here and call this as h2. आज मजा आने वाला है, तैयार हो जाओ. h1 is a perpendicular from the source to the mirror. h2 is a perpendicular from the image to the mirror. And of course, this distance between them is going to be a constant. I'll call it d. This point could be a variable point. I'll call it x, which is going to change. So this distance is going to become d minus x. Wonderful. I want to see how much geometry and थोड़ा सा calculus use करके क्या करने वाले हैं हम. हमको निकालना क्या है? हमको निकालना है यहां से यहां तक का डिस्टेंस प्लस यहां से यहां तक का डिस्टेंस. अगर मिनिमम है तो फिर Fermat's principle perfect है. What is this distance equal to? Can you tell me what this distance is? If this is x, this is h1, how much is this distance?
Root of x square plus h1 square.
Very good. So can I say that the total distance, suppose I call this as y, is equal to, what is this length equal to? You said h1 square plus x square whole to the power half, right? Plus, what about this distance? Carry on, carry on, carry on. Kya likhu? This square plus this square, h2 square plus, carry on, d minus
minus x the whole square.
Whole to the power half.
tick. That's the total distance. Now, Fermat says minimum distance. Now, tell me, how do I find minimum or maximum of a function? कैसे करते हैं?
The derivative.
Very good. Find the derivative. Derivative is basically dy by dx.
Yes.
If it is a maxima or a minima, dy by dx has to be equal to?
0.
Very good. You all know that? Can you? What is dy by dx, by the way? It's called a slope, right?
Yes.
And for a maxima or a minima, dy by dx should be 0. अब इधर आना. इसको differentiate करना, please. dy by dx करना. This is whole to the power half, so half will come here. This value will remain as it is. And this will reduce by 1, so this will become minus half, yes or no?
Yes.
Then I enter inside, this is a constant, 0. What will be x square equal to? Differential of x square will be 2x. 2x, half, side में आया, h1 square plus x square whole to the power minus half. पहले मैंने इस पूरे को डिफरेंशिएट किया, अब मैं अंदर जा रहा हूं, अंदर ये कांस्टेंट मिल रहा है, इसका डिफरेंशियल 0 होगा, ये x स्क्वायर है, इसका डिफरेंशियल 2x होगा. है ना? यस और नो? आगे चलते हैं. प्लस, मजा आने वाला है, हाफ साइड में आ गया, वैल्यू एज इट इज आ गई h2 स्क्वायर प्लस d माइनस x होल स्क्वायर होल टू द पावर माइनस हाफ. यू एग्री विद मी?
Yes.
अब इसका डेरिवेटिव कितना है? 0. इट्स अ कांस्टेंट.
0.
इसको डिराइव करेंगे तो क्या आएगा? पावर 2 है, 2 इंटू डी माइनस एक्स, 2 into d minus
minus 1.
and then, oh, very good, into minus 1 of minus 1. And this should be equal to, yes or no? Write this step, write these 2 steps, and in the third step, you will derive the result. Just write this down. Write these 2 steps, please, carefully. You're doing very well. You're understanding a good topic. You're understanding optics from where it should be. And I can see that you're all responding. Write these 2 steps very clearly. और इसके अगले स्टेप में खेला होने वाला है. जरा देखेंगे ध्यान से. देख लिया ना? Can I cut 2 with 2?
Mm-hmm.
Can I cut this 2 with 2? And
Yes.
there is a minus sign here. And this is equal to 0. हाँ जी, ठीक है ना? इसको मैं ओपन अप करता हूं. क्या लिखूं? X upon this whole thing. This is minus half, right? It will come down. h1 square plus x square whole to the power half. Yes or no? X
Yes.
upon. Yes. Very good. So there is a negative sign here or equal to 0. तो मैं इसको इधर ले जाता हूं. तो बचेगा क्या? d minus x. ओहो. Upon this whole thing. Oh God. Yes or no? Yes or no? If this
Yes.
total distance has to be minimum, I calculated this entire length. This length is this. This length is this. To find maxima minima, I need to differentiate it. I differentiated it. This half comes here. This becomes minus half. This x square becomes 2x. I move forward. This half comes here. This becomes minus half. This is 0. This is 2 into d minus x. Minus x becomes minus 1 equal to 0. Fabulous. Right. And you get this answer. एक बात ध्यान से देखना. What is this angle? I. तो ये कितना हो जाएगा? I. Alternate angles? ये क्या है यार? X upon this. ये angle I है. ये एक triangle है. What is this
Sin I.
value? What is this value?
Sin I.
What is this value?
Sin I.
Hello. And if this is R, this is also R. What is this value? D minus X upon
Sin
this.
R.
What have you proved? What have you proved? Sin I equals sin R. What does it mean? That angle I is equal to angle R. Yes, yes, yes. That's what it is. That's what it is.
Sir, I have a doubt.
Yeah, carry on. Carry on. Bolo.
Sir, why have we assumed the source point and the image point to be the maximum and minimum?
Nahi. Fermat suggested that any incident ray starting from a source, reflecting from a mirror, and forming an image, he experimentally found out that this entire journey of this ray it is the minimum distance which this ray through any other path could have taken. So an incident ray hitting a mirror and forming an image, this whole thing has to be minimum. What I did, I took a source of light, एक इंसिडेंट रे डाला, रिफ्लेक्ट करा के इमेज बनाया. अब अगर हम फॉर्मेट को फॉलो करें, so this length plus this length should be the minimum length. What we did, we calculated this length. We've calculated this length. We know to find maxima or minima, we need to differentiate this function. So we differentiated this function and put it equal to 0. We exactly did that. And that is where we landed. And that is where we finally landed. And that is finally, we have proved that the angle of incidence is equal to the angle of reflection. पहले आपको पता था कि फॉर्मेट से होता है. Can you explain? Yeah. Minimum time or minimum length. Velocity of light is same. So either you find minimum time or you find minimum length. So if I wanted to write length, then I'll measure this. And if I wanted to measure time, I would divide it by velocity. वो CC हर जगह cancel हो जाएगा. So that means this length plus this length should be the minimum length. And that is what Fermat actually said, that the angle of incidence is equal to angle of reflection, because this is the only case where the light has taken the minimum time or the minimum distance to form an image. तो वो सारी रेज, वो सारी की सारी इंसिडेंट रेज जो मिरर से हिट करके इमेज बनाएंगी, वो सब की सब रेज मिनिमम टाइम लेने वाली है, और वो सब की सब रेज सेम टाइम लेने वाली है, जो कि वो मिनिमम टाइम होने वाला है. That's what Fermat's principle is. And that's what the start point of light or optics is going to be. I hope you enjoyed this session, a small session of Fermat's principle. Did you like the session?
Yes.
Did you
Yes,
understand the session?
Yeah.
Very good. Very
Yes, sir.
good. Wonderful. Wonderful. I'm so happy to see that. You know, यार पढ़ने में थकान नहीं होती अगर पढ़ने में मजा आए, और पढ़ने में मजा तब आता है जब पढ़ाई चैलेंजिंग हो. You don't want to beat Bangladesh. India doesn't feel happy when they beat Bangladesh. India doesn't feel happy when India defeats Australia in India. We feel happy when we demolish them in Melbourne, at Perth, in their own home ground. And that's what life is all about. You only rise to the occasion if you defeat, challenge, accept challenge, the most important, difficult challenge, you accept it and you do it correctly. That is exactly why I wanted to come and meet you. I'm going to take your classes often. As I said, Mr. Praveen Tyagi, me, Acharya sir. There's so many teachers but Tyagi sir has told me that he wants me to take some sessions with you and help you and motivate you and make you better in physics. I hope you like the session. I'm going to see you next week. Next week, we are going to move forward from Fermat's principle to finding out how a ray is formed in a plane mirror. Now, when we say a plane mirror, the distance of the object from the mirror is equal to the distance of the image from the mirror. Incorrect. जानने की कोशिश करेंगे गलती क्या है इसके अंदर क्या डिस्टेंस ऑफ द ऑब्जेक्ट फ्रॉम द मिरर इज इक्वल टू डिस्टेंस ऑफ द इमेज फ्रॉम द मिरर पता है हमको सर ये गलत है ये गलत क्यों है ये जानने की कोशिश करेंगे every ray which gets reflected can I see an image no when do you see an image is not when a reflected light is formed you see an image when the reflected ray reaches your eye so if I have to see an image where should I be? Where should I be seen? Where should I be seen? I should be only seen. My eye should be only at that point where the reflected rays are reaching my eye. And there's so many other things we are going to discuss. I'm going to take some questions from JEE Mains. I'm going to do them with you. I've taught all my life, as I said, 27 years here. I'm going to spend another 3 years with you. You're in 10th, then in 11th, and then in 12th, and ensure that whatever you do it with all conviction. You're sure about what you're doing. आप जो बोल रहे हो वो आपको मालूम है.
Yes, sir.
Thank you. I love you all. And thank you for giving me an opportunity. I'll see you the next week. God bless. Stay healthy. And I'll see you next week. God bless you. Bye.
Bye, sir. Thank you, sir.
Thank you, sir. Bye.
Thank you. Thank you very much.